The universe is not the serene expanse we often imagine. Beneath the starry beauty lies a realm of profound and hidden terrors. We are about to journey through 25 of the cosmos' most chilling mysteries, from invisible forces tearing at reality to the ultimate fate that awaits everything. You will discover the genuine dangers lurking in the void, threats that are both scientifically real and deeply unsettling. What unseen horror could be pulling our entire galaxy towards an unknown destination? And why does the profound silence of space feel so ominous? Which of these cosmic fears do you find the most compelling? Your body is the most complex machine you will ever inhabit, yet it is designed for a single, fragile world. The instant you are exposed to the pure vacuum of space, that world is ripped away. The pressure that normally holds you together vanishes. This is not a Hollywood explosion, but something far more insidious. The water on your tongue and the moisture in your eyes would instantly begin to boil, not from heat, but from the absence of pressure, a terrifying process called ebullition. Your body would swell to nearly twice its size, yet your skin is just elastic enough to hold you together. Your lungs would forcefully expel their air in a silent, violent rush, and in less than 15 seconds, the oxygen left in your bloodstream would be depleted, plunging you into unconsciousness. For a brief, agonizing moment, you would be aware of the saliva boiling on your tongue before the blackness takes you. It is a death that is both physically grotesque and deceptively swift, a stark reminder that the cosmos is not merely indifferent to our existence, it is actively hostile to our very biology. While your body swells in the vacuum, an even more insidious threat passes through you completely unseen. Cosmic radiation is a constant, silent drizzle of death from the depths of the galaxy. These are not mere particles. They are atomic nuclei stripped of their electrons and accelerated to nearly the speed of light by distant supernovas and black holes. On Earth, our atmosphere and magnetic field act as a protective shield, deflecting this invisible barrage. But in space, there is no such protection. These high-energy particles slice through a spacecraft's hull as if it were not even there, and they slice through you too. Every second, these microscopic bullets are tearing through your cells, shredding your very DNA. The long-term effects are a stark reality for space agencies, a significantly increased risk of cancer, and studies now suggest potential damage to the brain, impacting cognitive function and memory. Perhaps the most unnerving evidence of this bombardment was experienced by the Apollo astronauts on their way to the moon. In the utter darkness of the capsule, with their eyes closed, they reported seeing sudden, brilliant flashes of light. These were not instrument panels or reflections. They were the direct result of a heavy ion, a piece of cosmic shrapnel, tearing through their optic nerve and fooling the brain into seeing a star that was not there. It is a haunting thought that even with your eyes shut, you cannot escape the violent, invisible universe. This relentless rain raises a chilling question for the future of space travel. How do you build a shelter from a storm that you cannot see, a storm that is already inside the ship with you? While cosmic radiation shreds your DNA from within, the simple absence of gravity is reshaping the human body in profoundly unsettling ways. Living in microgravity is like forcing your body into a state of accelerated and unnatural aging. Without the constant pull of gravity to work against, your muscles begin to waste away at an alarming rate. Astronauts must exercise for over 2 hours every single day just to slow the decline. But even that rigorous routine cannot stop the loss of bone density. Your skeleton, no longer needed for full support, starts leaching calcium into the bloodstream, becoming brittle and weak, a condition that mirrors severe osteoporosis. This is not a slow process of getting older. It is a rapid, forced decay. At the same time, the fluids in your body, no longer pulled downward, redistribute themselves evenly. This causes a strange phenomenon astronauts call puffy face bird leg syndrome. Your face becomes round and swollen, while your legs grow thinner as fluids migrate upward, often leading to persistent head congestion and an altered sense of taste. Perhaps the most alarming effect is on your eyesight. For many astronauts, the pressure changes inside the skull cause the backs of their eyes to flatten and their optic nerves to swell. This results in permanent changes to their vision, with many returning to Earth requiring glasses for the first time. Your entire biological system, evolved over millions of years for a world with gravity, begins to malfunction. The body you take for granted is not built for the void, and a long-term stay in space leaves a lasting physical mark, a ghost of the home world you left behind. But these dangers are not confined to the void between worlds. A threat of our own making now circles our planet, a silent catastrophe waiting to happen. High above us, in the very orbits we rely on for communication and navigation, a mathematical specter looms, known as the Kessler Syndrome. This is not a single explosion, but a chain reaction of destruction. Imagine one satellite, perhaps defunct or damaged, colliding with another at immense speed. That impact does not just destroy two objects, it creates thousands of new pieces of shrapnel, each one a high-velocity bullet. Each of those new fragments now has the potential to strike another satellite, creating more debris, which in turn hits more objects. Computer simulations of this event are terrifyingly clear. A single collision can trigger an unstoppable cascade. Within days or even hours, a critical orbit could transform from a useful highway into an impassable shooting gallery. A dense cloud of metallic shrapnel would encircle the Earth, moving at speeds exceeding 17,000 miles per hour. At that velocity, even a paint chip can carry the energy of a hand grenade, capable of crippling the International Space Station or any other spacecraft that dares to pass through. The ultimate horror of the Kessler Syndrome is its permanence. In the vacuum of space, there is no air resistance to slow this debris down. Once the cascade begins, it could render entire orbital pathways unusable for centuries, effectively building a prison of our own garbage. We would be trapped on our own planet, with access to the stars permanently severed. Our satellites for weather forecasting, global communications, and scientific observation would be systematically pulverized into more debris, pushing our modern civilization back into a darker age. The launch of a new rocket would become a suicidal gamble, navigating a minefield where a single, unseen piece of wreckage could end the mission in a flash. We are already flirting with this future, with millions of pieces of trackable debris already in orbit. The question is no longer if a major collision will occur, but when. And when it does, will it be the one that locks the celestial gate behind us forever? The debris field we have created is a cage of our own design, but a cage can at least be seen. A far more ancient and mobile threat drifts through the darkness between the stars, completely invisible until it is too late. These are rogue planets, dark worlds that have been violently ejected from their birth solar systems, sent careening into the endless interstellar night. They are cosmic orphans, adrift in a perpetual and absolute deep freeze. Without a star to warm them, their surfaces plunge to temperatures colder than anything naturally occurring on Earth, a barren landscape of frozen rock and ice where the very atmosphere may have collapsed into a layer of snow on the ground. They wander in eternal darkness, their only light the distant, unblinking pinpricks of galaxies they will never reach. The true horror, however, lies not in their solitude, but in their potential to pass through our own celestial neighborhood. Imagine the gravitational disturbance caused by such a massive, unseen object slipping through our solar system. Its immense pull would act like a hidden wrecking ball, subtly yanking on the delicate orbital dance of every planet, moon, and asteroid it passed. It could nudge a stable orbit into a chaotic ellipse, sending a shower of comets from the distant Oort cloud hurtling inward toward the inner planets, including our own. The sky would appear unchanged to the naked eye, a starfield with a new, faint point of light moving slowly against the background. Yet beneath that serene appearance, the clockwork of our solar system would be thrown into disarray, a silent and unstoppable rearrangement of the heavens with consequences that could echo for millions of years. This is not the drama of an impact, but the slow, creeping dread of a gravitational ghost passing through our home, leaving chaos in its wake without ever making a sound. A rogue planet's silent passage is a ghostly threat, but some cosmic horrors announce their presence with an undeniable and terrifying gravity. Black holes are the universe's ultimate predators, regions of space where gravity has become so overwhelmingly powerful that not even light can escape their grasp. The boundary of this point of no return is called the event horizon, a spherical shell from within which no signal, no cry for help, and no particle of matter can ever reach the outside universe. To cross it is to be erased from the cosmic record forever. The popular image of a black hole is a giant vacuum cleaner, sucking everything in from a great distance. This is a myth. Their gravity behaves just like that of a star until you get dangerously close. You could orbit a black hole just as Earth orbits the Sun, but if you stray too near, you cross a threshold into a realm of physics so extreme it becomes a nightmare. The most visceral of these horrors is a process with a chillingly descriptive name, spaghettification. As you fall feet first toward a stellar mass black hole, the pull of gravity on your feet is vastly stronger than the pull on your head. This difference in force, the tidal force, stretches you lengthwise into a long, thin stream of atoms. You are not just crushed, you are pulled into a single strand of human spaghetti. For supermassive black holes, like the one at the center of our galaxy, the event horizon is so far from the central point that the tidal forces are weaker. You might cross the event horizon intact, but your fate is just as sealed. From your perspective, nothing dramatic happens at that moment, but to any outside observer, you would appear to slow down, redden, and fade away, frozen in time at the edge of the horizon, a permanent ghost in the machine. This leads to one of the most profound puzzles in all of physics, the black hole information paradox. According to our current understanding, information cannot be destroyed. Yet, if an object falls into a black hole, and the black hole eventually evaporates, as Stephen Hawking theorized, what happens to all the information that made up that object? Does it truly vanish, violating a fundamental law of the universe? Or is it somehow preserved in a way we cannot yet comprehend? Films like Interstellar gave us a stunning, if artistic, visualization of these behemoths, a swirling disk of superheated gas and light warping the very fabric of space and time around a luminous ring of fire. The reality is even stranger, a gravitational grip so absolute it doesn't just kill you, it unravels the very laws of physics as we know them. The silent, gravitational menace of a black hole is a localized terror, but the universe can unleash destruction on a truly galactic scale. Gamma-ray bursts are the single most violent explosions since the Big Bang itself. In the span of just a few seconds, one of these events can release more energy than our sun will emit over its entire 10 billion year lifetime. They are the universe's flashbangs, catastrophic detonations that outshine entire galaxies. These bursts are thought to be the birth cries of black holes, occurring when a massive star collapses in a hypernova, or when two ultra-dense objects like neutron stars spiral together and merge. For a brief, blinding moment, they focus twin beams of pure, high-energy radiation, like the beams of a cosmic lighthouse, but one that signals utter annihilation. If such a beam were to be pointed at Earth from within our own galaxy, the consequences would be apocalyptic. The initial flash of gamma rays and X-rays would be only the beginning. This wave of radiation would not just pass through us, it would chemically dismantle our planetary shield. Striking the upper atmosphere, it would rip apart the molecules of our ozone layer, the very thing that protects all life on the surface from the sun's deadly ultraviolet radiation. In a matter of days, that protective layer would be devastated. The animated graphic would show a serene blue planet, its atmosphere suddenly struck by an invisible wave. A shimmering, destructive ripple spreads across the globe, and as it passes, the vibrant ozone layer visibly withers and fades away, leaving the world exposed and vulnerable beneath a newly hostile sky. The result is a slow, gruesome extinction event. With the ozone layer gone, the surface would be bathed in lethal levels of ultraviolet radiation. The base of the food chain, phytoplankton in the oceans, would die off. Crops would fail on a global scale. Ecosystems would collapse from the bottom up. Any complex life caught in the open would suffer severe radiation burns and mutations. It is a sterilization from the heavens, not with fire and impact, but with an invisible poison that unravels the very fabric of our biosphere. We have likely been grazed by such events in the distant past, with some scientists theorizing a gamma-ray burst may have been responsible for the Ordovician mass extinction over 400 million years ago. We are safe only through sheer cosmic luck, relying on the fact that these devastating beams are not currently aimed our way. But the question lingers: how many other worlds, once teeming with life, have been silently scrubbed clean by a random flash from the depths of space? Our entire galaxy is caught in a relentless current, moving at over 1 million miles per hour towards something we cannot see. This is the mystery of the Great Attractor, a colossal gravitational anomaly located in the depths of intergalactic space. It is a focal point of immense gravity, so powerful that it is pulling our Milky Way and thousands of other galaxies in our local supercluster toward an unknown destination. We are part of a river of stars on a journey to a place we do not understand. The true horror of this situation is not the movement itself, but our profound blindness. The Great Attractor lies in the direction of the constellation Centaurus, a region of the sky that is completely obscured from our view by the central bulge of our own galaxy. This is what astronomers call the zone of avoidance. The dense clouds of stars, gas, and dust that form the heart of the Milky Way create an impenetrable wall, blocking our sight in that crucial direction. It is as if we are trying to navigate a vast ocean, pulled by a powerful whirlpool, but we are stuck in a cabin with the front window completely blacked out. We can feel the motion, we can measure the inexorable pull, but we cannot see what is doing the pulling. For decades, this was one of astronomy's greatest frustrations. We knew something of staggering mass was out there, a gravitational anchor point for our entire galactic neighborhood, yet it remained a phantom in the data. How do you study a monster that is hiding behind a curtain of its own making? The development of space-based X-ray telescopes and radio astronomy has begun to pierce that veil, revealing that the great attractor is not alone. It appears to be part of an even larger structure, a mind-numbing concentration of mass known as the Laniakea supercluster, of which we are just a remote outlying suburb. The pull we feel is the gravitational draw of this entire cosmic continent, yet the fundamental unease remains. We are being drawn toward a gravitational heart of darkness, a place where the normal rules of the universe are warped on a scale we can barely comprehend, and we are flying toward it blind. What ultimate structure or void lies at the end of this journey? And what does it mean for the distant future of our galaxy to be falling into such an immense gravitational well? The cosmos is not just random. It is organized by forces we are only beginning to sense, forces that can pull us across the void without ever revealing their face. Our galaxy is being pulled toward an unseen monster, yet the deeper silence is not behind us, but all around us. This is the Fermi Paradox, a question so simple it chills the soul. If the universe is so vast and ancient, with billions of planets that could support life, then where is everybody? The cosmos should be teeming with civilizations, its pathways bustling with interstellar traffic. Instead, we are met with an unnerving and absolute quiet. This profound silence is more terrifying than any signal we could possibly receive, because it suggests something is terribly wrong. One of the most unsettling explanations for this quiet is known as the Great Filter. This hypothesis proposes that there exists a barrier, a single, nearly impossible challenge that prevents life from advancing to the stars. This filter could lie in our past, a step so difficult that we were incredibly lucky to pass it. Perhaps the jump from non-living chemistry to the first self-replicating cell was a fluke of cosmic proportions, a 1 in a trillion event. Or maybe the evolution of complex, intelligent life is the true bottleneck. If this is the case, we have already passed through the filter, and we are truly alone in a galaxy of silent, barren worlds. The more terrifying possibility is that the Great Filter awaits us in our future. There could be a wall that every advancing civilization eventually hits, a point of technological maturation that leads to its own inevitable destruction. This could be a climate catastrophe we cannot reverse, a nuclear war no one survives, or a biotechnology that accidentally erases its creators. Perhaps the very act of discovering a certain branch of physics unlocks a power so destructive it cannot be contained. The silence, then, is not a sign of our solitude, but a graveyard. Every civilization that rose before us reached this same point of promise, looked out at the stars, and was then silenced forever. Our continued existence may not be a sign of our success, but merely a mark that we have not yet reached the precipice. We are broadcasting our presence into a quiet that may be quiet for a reason, a warning we are too young to understand. This profound silence is broken only by the ticking of a cosmic clock, one that is counting down to an inevitable end. Our sun, the steady giver of life, is also its future executioner. This is not a speculative threat from the depths of space, but a guaranteed fate written into the very laws of physics that govern our star. Right now, the sun is in the prime of its life, a stable main sequence star fusing hydrogen into helium in its core. But this stability is temporary. In about 5 billion years, the hydrogen fuel in its core will finally be exhausted. With the central engine sputtering, the delicate balance between the outward push of fusion and the inward crush of gravity will shatter. Gravity will win, causing the core to contract and heat up dramatically. This collapse will ignite a desperate, last-ditch fusion reaction in a shell of hydrogen surrounding the core. The energy from this shell burning will be so immense that the sun's outer layers will balloon outward, transforming our familiar yellow star into a monstrous red giant. It will swell to over 200 times its current diameter. The inner solar system will be consumed. Mercury will be the first to vanish, swallowed whole by the advancing wall of plasma. Venus will follow, its thick atmosphere stripped away before the planet itself is digested. Then, the sun's outer atmosphere will reach Earth. Our planet will not be instantly vaporized, but will instead be subjected to a slow, agonizing death. The first sign will be the sky itself changing. The sun will begin to swell, day by day, its red hue deepening until it fills a terrifying portion of the heavens. Imagine looking up to see a dull, red orb that covers half the sky, its surface a churning cauldron of magnetic storms. The heat on Earth will become unbearable. The oceans will not just evaporate, they will boil. The entire hydrosphere will turn into a thick, superheated steam atmosphere, scouring the continents clean of any remaining life. The rocks themselves will begin to glow a dull red, and the surface temperature will rise to thousands of degrees. The planet we knew will be reduced to a molten blob of rock and metal, its orbit slowly decaying as it plows through the tenuous outer layers of the dying star. Eventually, Earth will be completely engulfed, its atoms scattered and assimilated into the sun's expanding envelope. The entire history of our world, every mountain, every ocean, every memory of life, will be erased in a final, fiery embrace. After this violent expansion, the sun will shrug off its outer layers entirely, creating a beautiful but brief planetary nebula, while its core will collapse into a dense, Earth-sized ember known as a white dwarf. This stellar corpse will then cool for trillions of years, a fading cinder in a system of dead and scattered worlds. The horror is not in the surprise, but in the certainty. Our world has an expiration date, and the source of all life is also the instrument of its ultimate destruction. Even the graveyard silence of the Fermi Paradox pales next to a different kind of cosmic dread, one born not from absence of life, but from an absence of everything. Lying in the constellation of Boötes is a void so vast and empty it defies comprehension. This is not a simple gap between galaxies. It is a spherical chasm in the fabric of the universe, nearly 1 billion light-years across. To put that in perspective, if the Milky Way were a grain of sand, the Boötes void would be a hollow sphere over 6 miles wide. And within this incomprehensible volume, there are almost no galaxies. Where astronomers would expect to find tens of thousands of island universes, they have cataloged only a few dozen, lost in a darkness so profound it feels intentional. This is not just empty space. It is a desert on a cosmic scale, a region where the fundamental structure of the cosmos seems to have broken. The existential dread it provokes is unique. We fear predators and explosions, but the Boötes void presents a terror of pure, unadulterated nothingness. To be adrift there would be to experience the ultimate isolation. The night sky would be almost perfectly black, the familiar constellations and the hazy band of the Milky Way completely gone. The only points of light would be the rare, lonely galaxies, each one an unimaginably distant and unreachable island in an ocean of void. You could travel for millions of years at light speed and see nothing but an unbroken, inky blackness in every direction. How does such a place exist? The leading theory suggests it is a remnant of the universe's birth, a giant cosmic defect. In the first moments after the Big Bang, the fabric of spacetime may have stretched unevenly, creating vast bubbles and voids. The Boötes void could be one of these primordial bubbles, a region that simply never had the density of matter needed to form galaxies. It is a fossil from the dawn of time. Yet its sheer scale is so extreme that some more speculative ideas have emerged. Could it be the result of something more sinister? What if an incomprehensibly advanced civilization, one that had mastered the energy of entire galaxies, somehow harvested every star in this region, leaving behind only a sterile, dark monument to its power? The void would then be a warning, a signature of a technology so vast it can rearrange the cosmos itself. Whether a natural flaw or something else, the Boötes void stands as a chilling reminder that the universe is not uniformly filled with light and structure. There are holes in the cosmic map, abysses of nothing so deep they challenge our understanding of reality itself. What other immense and empty structures are waiting to be found in the darkness between the stars? The profound emptiness of the Boötes void is a terror of absence, but the cosmos also creates monsters of relentless, rhythmic presence. Out in the darkness, celestial lighthouses sweep the void with beams of pure annihilation. These are pulsars, the rapidly spinning corpses of massive stars that died in supernova explosions. Each one is a neutron star, an object so dense that a single teaspoon of its material would weigh billions of tons on Earth, compressed into a sphere only about the size of a city. But it is their spin that transforms them from inert corpses into cosmic death rays. A pulsar can rotate hundreds of times per second, and as it spins, it sweeps narrow, powerful beams of radiation from its magnetic poles across space. If one of those beams passes over your location, you detect a pulse of energy, a flash in the radio, X-ray, or even gamma-ray spectrum. This creates a rhythm of breathtaking precision, a metronome ticking with a stability that rivals atomic clocks. The sound of these signals, when translated into audio, is deeply unsettling. It is not a random static, but a rhythmic, mechanical pulse, a beacon in the dark that sounds more like a machine than a star. That rhythmic pulse, however, is a siren song of destruction. The environment immediately around a pulsar is a maelstrom of forces beyond human engineering. Its magnetic field is a trillion times stronger than Earth's, a force so powerful it could tear the iron from your blood from a distance of tens of thousands of miles. Any spacecraft venturing too close would be subjected to this relentless, rotating barrage. The pulsar's beams are not just light. They are a torrent of high-energy particles and radiation that would instantly fry all electronics and bombard any crew with a lethal dose of radiation in milliseconds. It is a lighthouse whose guiding beam does not warn of rocks, but is itself the killing stroke. To be caught in the open near a pulsar would be to experience a death by rhythmic, precise irradiation, a slow cook or an instant flash depending on your distance from that spinning blade of energy. These cosmic sentinels stand as a reminder that even the corpses of dead stars can be more violently active than our living sun, turning the graves of stars into some of the most hazardous environments in the entire galaxy. The rhythmic death of a pulsar is a violent spectacle, yet it is a finite event in a cosmos facing an end far more absolute. The universe itself is dying, not with a bang, but with a slow, inexorable sigh. This is the heat death, the ultimate fate awaiting all of reality. It is a conclusion dictated by a fundamental law of physics, entropy, which is the universe's measure of disorder. Simply put, everything tends from order to chaos, from concentration to diffusion. A cup of hot coffee cools to room temperature, its concentrated heat spreading out into the air until equilibrium is reached. The universe is doing the same thing on a cosmic scale. All the energy and matter, currently concentrated in blazing stars and swirling galaxies, is slowly but inevitably spreading out. Stars are the engines fighting this decay, fusing hydrogen into helium and releasing immense energy. But every star is a finite reservoir of fuel. One by one, they will all burn out. The massive blue giants will be the first to go, exploding in supernova. The stable stars like our Sun will swell into red giants and then fade into white dwarfs. The small, frugal red dwarfs will shine for trillions of years, but even their faint light will eventually flicker and die. The last star in the universe will one day exhaust its fuel, and with its final photon emitted, eternal night will truly begin. The cosmos will be littered with the cold, dark corpses of stars, black holes, and frozen planets, drifting in an expanding void. But the end is not just darkness, it is a profound and universal stillness. Black holes, once thought to be eternal, are not immune. Through a quantum process discovered by Stephen Hawking, they slowly evaporate, radiating away their mass over incomprehensible eons. Even these gravitational titans will eventually pop out of existence. What remains is a universe in a state of maximum entropy. All energy is evenly distributed across an infinite and ever-expanding space. The temperature everywhere approaches absolute zero, the point where all atomic motion ceases. There are no hot spots or cold spots, no stars or planets, no light or heat. There is no energy gradient left to power any process, not a thought, not a chemical reaction, not the flutter of a single atom. It is a perfect, uniform, and lifeless equilibrium. This is a fate far more chilling than a dramatic big crunch, a hypothetical collapse back into a singularity. That would be a violent, fiery end, but an end with a final, catastrophic event. The heat death offers no such drama. It is the universe falling not into sleep, but into a coma from which it will never wake. A silence so complete it makes the Fermi Paradox seem like a noisy party. This is the final, inescapable horror, the day the cosmos runs out of not just stories, but the ability to ever tell one again. Our sun is not a placid ball of light, but a churning sphere of plasma with a violent and unpredictable temper. While it provides the energy for all life, it can also unleash storms powerful enough to dismantle the very framework of our modern world. The most dangerous of these eruptions are solar flares and their more massive cousins, coronal mass ejections. A flare is a sudden, intense flash of radiation, a cosmic flashbulb that floods the solar system with X-rays and ultraviolet light. But a coronal mass ejection is an event of a different magnitude. It is the sun literally vomiting a billion tons of its own superheated plasma, a cloud of charged particles and tangled magnetic fields, directly into space. This cloud can travel at millions of miles per hour, and if Earth is in its path, the consequences are catastrophic. We have experienced a direct hit before. In 1859, a solar storm of unprecedented power, now called the Carrington Event, struck our planet. The result was a global spectacle of auroras, with the northern lights seen as far south as the Caribbean. But for the primitive telegraph systems of the era, it was a disaster. Wires sparked and caught fire, operators received severe shocks, and some lines continued to send messages even after being disconnected from their power sources. That was with the simple technology of the 19th century. A similar event today would not be a beautiful light show. It would be an extinction-level event for our digital civilization. The moment that cloud of charged particles slams into Earth's magnetic field, the entire planet rings like a bell. The resulting geomagnetic storm induces colossal electrical currents in anything long and metallic, most critically in our continental power grids. Imagine a surge of power, not from a downed wire, but from the planet itself, flooding into transformers and substations. These multi-ton pieces of equipment, the backbone of our electrical infrastructure, would not just switch off, they would melt, explode, and burn. The failure would be cascading and rapid. A simulation of such an event shows a domino effect of darkness. First, one region goes black as its grid fails under the strain. Then another and another as automated systems are overwhelmed. Within minutes, an entire continent could be without power, and this would not be a blackout that lasts for days. The real horror is the timescale. These transformers are not items kept in warehouse stock. They are custom-built, each one weighing hundreds of tons. Manufacturing and replacing them on a global scale could take years, perhaps even a decade. In the meantime, there is no grid. There is no running water, no refrigeration, no fuel pumps, no sewage treatment, and no digital communication. Satellites in orbit, blinded and fried by the radiation, would tumble out of control, destroying global positioning, communications, and weather forecasting. We would be plunged in an instant from the 21st century to a pre-industrial age, but with 8 billion people utterly dependent on the system that just vanished. The Carrington event was a warning shot. Scientists estimate there is a significant chance of a storm of similar or greater power hitting us in the next few decades. Our civilization now hangs by a thread woven from copper and silicon, vulnerable to the next tantrum of our parent star. Our civilization is fragile before the sun's fury, but even our star is a mere speck in a cosmos governed by forces we cannot see. The very fabric of the universe is woven from shadows. Everything we have ever observed, every star, galaxy, and nebula, every particle that makes up our bodies and our world, accounts for less than 5% of reality. The rest is a profound and unsettling mystery, a dual phantom haunting the cosmos, dark matter, and dark energy. We know dark matter exists only because of its ghostly grip. When astronomers measure the rotation of galaxies, they find a startling anomaly. The stars on the outer edges swirl just as fast as those near the brilliant core. According to the laws of gravity, this should be impossible. A galaxy without some form of invisible scaffolding should fly apart, its outer stars flung into the void. The only explanation is that each galaxy is embedded within a vast, spherical halo of something that does not emit or reflect any light, a substance whose gravity is the only thing holding these cosmic islands together. This dark matter is the hidden architecture of the universe, a cosmic glue we can neither see nor touch, yet without it, our Milky Way would not exist, and neither would we. But if dark matter is the glue, dark energy is the solvent. In the late 1990s, astronomers made a discovery that shattered our understanding of cosmic destiny. They found that the expansion of the universe is not slowing down due to gravity, as everyone had assumed. It is accelerating. Something is actively pushing space itself apart, and that something has been named dark energy. This is not an explosion from a past event. It is a property of the vacuum of space itself, a repulsive force that grows stronger as the universe expands. Think of the cosmos as a loaf of raisin bread baking in an oven. The raisins are galaxies. Dark matter is the floury dough that holds each raisin cluster together. But dark energy is the yeast in the dough, causing the entire loaf to expand at an ever-increasing rate, pushing the raisins farther and farther apart from one another. This leads to a future of cosmic isolation so profound it defies imagination. As dark energy's push overwhelms the pull of gravity, galaxy clusters will be torn from one another's gravitational embrace. The light from all other galaxies will redshift into invisibility. In a future trillions of years from now, any civilization born in our own Milky Way will look out into a black, empty void. They will see no other galaxies, no evidence of a larger cosmos. The universe will appear to them as a single, lonely island in an endless, static night. All evidence of the Big Bang and the grand, structured universe we see today will be gone, erased by the relentless push of the dark. The ultimate horror is not just that we do not know what 95% of the universe is, but that this unknown majority is actively shaping a future of utter loneliness, a destiny written in invisible ink across an ever-darkening sky. The profound silence of space was broken just once, by a signal so perfect it seemed to scream intelligence. On August 15, 1977, a radio telescope at Ohio State University known as the Big Ear was performing its routine scan of the heavens. A few days later, a volunteer named Jerry Amon was sifting through the reams of printed data, a long scroll of numbers and letters. His eye caught a sequence so startling that he circled it in red pen and wrote one word beside it: wow. The signal itself was not a message we could understand, but its characteristics were exactly what scientists had predicted for a genuine transmission from another civilization. It was a narrowband signal focused on one specific frequency, the emission line of neutral hydrogen, which is considered a natural cosmic channel, a logical place to call out across the galaxy. It was incredibly powerful, blasting through the background static, and it lasted for 72 seconds, the precise duration the Big Ear telescope would observe a single point in the sky as the Earth rotated. It came from the direction of the constellation Sagittarius, rose in intensity to a peak, and then faded away exactly as expected. It was a perfect hit. The dread comes not from the signal itself, but from what happened next, or more accurately, what did not happen. Astronomers pointed every available telescope back at that same spot in the sky. They listened for years, then for decades. They scanned that same frequency and thousands of others. They never heard it again, not a whisper, not a repeat. It was a single, deafening cosmic shout, followed by an absolute, unbroken silence that has now lasted for over 45 years. Was it a message that was sent once and never repeated? Did the civilization that sent it vanish in a cataclysm immediately after its transmission? Was it a powerful beacon sweeping through space, and we just happened to drift through its beam for 72 fleeting seconds? Or perhaps the most unsettling thought of all, was it a signal meant for someone else, and we simply overheard a single, cryptic fragment of a conversation not intended for our ears? The WOW signal remains a solitary data point, a ghost in the machine of cosmic search. It is the ultimate tease, a piece of evidence that is both compelling and utterly useless, proving nothing except that the universe is capable of producing a sound that looks exactly like a hello, only to swallow it back in the void forever. The perfect silence of the WOW signal leaves us listening for a voice, but the galaxy holds predators that make no sound at all. We have already met the supermassive black hole at the galactic core, a predictable monster in its lair. Far more terrifying are the wanderers, the stellar mass black holes that drift unseen through the cosmic voids between the stars. These are the ghosts of dead suns, born in the violent collapse of massive stars, and then given a silent kick by the forces of their own death, sent careening across the galaxy without a star to call home. They are the ultimate invisible hunters, their presence betrayed only by the subtle warping of spacetime in their immediate vicinity. A typical stellar black hole might possess the mass of 10 suns compressed into a sphere just 30 miles across. Its event horizon, the point of no return, would be deceptively small, a target you could cross in an instant without ever seeing it coming. The true horror lies in their motion and their appetite. Drifting at incredible speeds, such a black hole could enter our solar system completely undetected until its gravitational influence began to pluck at the orbits of the outer planets. Long before any telescope saw it, we would notice the subtle, inexplicable wobbles in the paths of Neptune and Uranus, a celestial disturbance with no visible cause. By the time its gravity began to perturb the asteroid belt, sending a storm of rocks inward, it would be far too late. If it passed through the inner solar system, its tidal forces would be catastrophic. It would not need to directly impact a planet to destroy it. Passing near Earth, its gravity would warp our planet into an egg shape, triggering global earthquakes and volcanic eruptions on an unimaginable scale. The oceans would slosh onto the continents, and the atmosphere would be ripped away into a swirling, hot accretion disk around the intruder. The planet would be physically torn apart from the inside out, its materials spiraling into the black hole in a brilliant, final flare of X-ray light. This is not a slow death like the expanding sun, but a sudden, unexpected erasure. The most chilling part is the statistical certainty. Astronomers estimate there could be as many as 100 million of these rogue black holes wandering the Milky Way. We have only confirmed a handful, and only when they are actively feeding, pulling gas from a companion star, or bending the light of a more distant one in a process called gravitational microlensing. For every one we see, countless others move through the darkness, silent and sated. Our solar system is a ship sailing through a minefield where the mines are completely black and exert an irresistible pull. One could be passing through our neighborhood right now, a few light years away, and we would have no way of knowing it was there until the delicate clockwork of our solar system began, quietly and inexorably, to unravel. The silent drift of a rogue black hole is a threat from without, but the very flow of time itself can become a prison for the human soul. Einstein's theory of relativity reveals a terrifying truth about high-speed travel. The faster you move through space, the slower you move through time. This is not a philosophical idea. It is a hard, physical reality, confirmed by incredibly precise atomic clocks on fast-moving jets and satellites. For an astronaut on a journey to a distant star at a significant fraction of light speed, this effect becomes a profound personal tragedy. Imagine a mission to a star system 100 light years away. For the crew on a ship moving at 90% the speed of light, the journey might feel like it takes only a few decades due to time dilation. They live their lives aboard the ship, watching their children grow up in video messages, celebrating milestones from an unimaginable distance. But when their mission is complete and they return home, they do not find the world they left behind. While 50 years pass for them, over 100 years have flowed on Earth. They step out of their ship as middle-aged explorers, but the planet they return to is the future. Everyone they ever knew, their parents, their siblings, their lifelong friends, are all gone, having lived full lives and died of old age decades ago. Their own children, if they had any, would be elderly or deceased. They are ghosts in their own homeland, surrounded by strangers who view them as ancient relics, living artifacts from a bygone era. Their memories are of a world that no longer exists, their loved ones preserved only in fading photographs and data files. This is a form of time travel, a one-way ticket in the future, but it carries the ultimate price of absolute loneliness. You do not get to experience the future with your loved ones. You arrive after their story is already over. This is the cruel paradox of relativity. a law of physics that allows you to conquer space, but only by sacrificing your own time and every meaningful connection you ever had. Our own moon holds a silence more profound than any void between the stars. We see its familiar face in our night sky, but the far side is a world permanently hidden from our view, a place of perpetual radio silence. This is not a land of eternal darkness, as the myth suggests. It experiences the same 2-week-long day and night cycle as the side we see. The true horror is not a lack of sunlight, but a profound and inescapable isolation. Because the moon is tidally locked to Earth, it rotates at the exact same rate as it orbits us. This means one hemisphere is forever pointed away, shielded from the constant radio chatter of our civilization. To stand on the far side is to be utterly cut off. You could look up and see the starry blackness of space, but Earth would be nowhere in your sky. It is the only place in the solar system where our planet is never visible, a loneliness on a cosmic scale. This very isolation, however, makes it a perfect ear to the universe. Shielded from our radio noise, the far side can hear the faint, ancient whispers of the cosmos that are drowned out everywhere else. Here, scientists can detect strange, low-frequency radio signals that have traveled for billions of years. These are not alien messages, but something almost as profound, the faint afterglow of the universe's birth and the violent deaths of its first stars. It is a window into the cosmic dark ages, a time before the first galaxies even formed. This silent hemisphere acts as a pristine recording device, capturing the faint echoes of creation itself. Yet, this also means that any mission on the far side is on its own. The moment a lander dips below the craggy horizon, all communication with Earth is instantly severed. There is no mission control, no reassuring voice from home, only the deafening quiet and the knowledge that you are listening to the ghostly radio signals of a dead universe, completely alone. Our own galaxy is a predator. The serene spiral of the Milky Way, a familiar sight in our night sky, is in fact a cosmic cannibal, its graceful arms hiding a history of violent consumption. This is the process of galactic cannibalism, a slow-motion feast where larger galaxies like ours tear apart and devour their smaller neighbors. The gravitational pull of a massive galaxy is an irresistible force, and when a smaller dwarf galaxy wanders too close, it is doomed. The smaller galaxy does not simply crash into the core, it is methodically shredded over billions of years. Immense tidal forces, the same kind that stretch a human near a black hole, but on an unimaginably vast scale, pull the dwarf galaxy apart. Its stars are stripped away, drawn out into long, shimmering rivers of light that wrap around the predator like celestial spaghetti. These are tidal streams, the ghostly remains of a galaxy being digested, its stars slowly becoming indistinguishable from those of the cannibal that consumed it. We can see this process happening right now in our own cosmic backyard. The large and small Magellanic Clouds, those two fuzzy patches of light visible from the southern hemisphere, are not permanent companions. They are dwarf galaxies caught in a deadly gravitational dance with the Milky Way. Over the next few billion years, the immense tidal forces of our galaxy will relentlessly pull them closer, stretching them, warping them, and finally tearing them to pieces. Their stars will be siphoned off, joining the vast halo of the Milky Way, leaving behind only faint, dissolving streams of stars as a monument to their existence. Visualize a simulation of this cosmic demolition, two smaller, irregular galaxies swinging past the colossal spiral of the Milky Way. With each pass, long tails of stars are ripped from their bodies, swirling around the larger galaxy in a beautiful, tragic dance of destruction. This is not a collision of fire and explosion, but a slow, gravitational unraveling. The devoured galaxy loses its identity, its structure, its very soul, all to feed the growth of the giant. Our Milky Way's current majestic form was built on a diet of such smaller galaxies, and its hunger is not yet sated. This cycle of creation through destruction is woven into the fabric of cosmic evolution. Every large galaxy we see today stands atop a graveyard of its former neighbors. Even the most carefully planned journeys can be haunted by a ghost in the machine. As the Pioneer 10 and Pioneer 11 spacecraft completed their grand tours of the outer planets and began their long voyage into interstellar space, scientists tracking their trajectories noticed something deeply wrong. Both probes were experiencing a tiny, unexplained deceleration, a constant, faint tug back toward the inner solar system. This was the Pioneer anomaly, a whisper of a force that should not have been there. The pull was incredibly subtle, less than a billionth of the gravity we feel on Earth, but it was persistent and identical for both spacecraft, as if some unseen hand was gently applying the brakes. For decades, this minuscule drift defied all conventional explanation. Engineers performed a meticulous autopsy on the mission data, searching for a prosaic cause. Could it be the gentle push of leaking propellant from a tiny fuel line crack? Was it the faint thermal radiation, the simple heat radiating from the spacecraft's electronics and nuclear power source, acting like a soft photon breeze pushing back against its direction of travel? The scientific method demands that you rule out the ordinary before embracing the extraordinary, and for a long time, the thermal explanation seemed the most likely culprit. Yet the anomaly's grip on the scientific imagination never faded, because the implications of a new physical force were so profound. What if this was not a spacecraft engineering problem, but a crack in our understanding of gravity itself? Perhaps Einstein's theory of relativity, the very foundation of modern physics, needed a slight modification at the extreme scales of the solar system. Or maybe the probes were plowing through a diffuse halo of dark matter, feeling the drag of invisible particles as they sailed into the void. The Pioneer anomaly was a mystery that refused to die, a constant low hum of wrongness in the precise mathematics of celestial mechanics. It was a reminder that even in the vast, seemingly predictable emptiness, we might be missing a fundamental piece of the puzzle, a hidden rule of the cosmos that only reveals itself on the longest, loneliest journeys. The same destructive power that creates a wandering black hole can, when anchored at the heart of a galaxy, ignite a beacon of pure annihilation. Quasars are the most violently energetic objects in the known universe, the active hearts of distant galaxies where a supermassive black hole is engaged in a cosmic feeding frenzy. Imagine a black hole with the mass of 1 billion suns, and then picture a colossal whirlpool of gas and dust swirling around it at nearly the speed of light. As this material is dragged toward the event horizon, it compresses and heats to millions of degrees, blazing with a light that can outshine every single star in its host galaxy combined. This is not a gentle glow. It is a continuous thermonuclear explosion focused into two opposing beams that scream across the cosmos. The environment around a quasar is a place where physics reaches its absolute breaking point. Any planet forming in that galaxy, even one in a quiet stellar neighborhood far from the core, would be sterilized. The quasar bathes its entire galactic home in an unending storm of X-rays and gamma radiation, scouring away atmospheres and boiling away oceans. It is a galactic-scale ultraviolet lamp, permanently set to kill. The sheer luminosity is so immense that we can see these objects from the very edge of the observable universe, their light having traveled for over 13 billion years to reach us. We are essentially looking back in time at the universe's violent youth, when such monsters were common. The quasar is a terrifying paradox, a symbol of creation and destruction woven into one. The same gravitational engine that can gather matter to form stars and planets, when starved of control, becomes a destroyer of worlds on an unimaginable scale. It proves that a galaxy can be both a cradle for life and its ultimate incinerator, all depending on the appetite of the sleeping giant at its center. Beyond the last planet's orbit, where the sun is a mere pinprick of dull light, lies a frozen graveyard of primordial debris. This is the Oort cloud, a spherical shell of icy planetesimals enveloping our entire solar system in a ghostly haze. Its outer edge is the true boundary of the sun's gravitational influence, nearly a light year away, a distance so vast it makes the orbit of Neptune seem like a tight inner circle. These are not the rocky asteroids of the inner system, but ancient, dirty snowballs, the leftover building blocks from the solar system's violent birth, held in a deep freeze for 4.5 billion years. They drift in an unimaginable stillness, their orbits so long and slow that a single pass around the sun can take millions of years. The horror of this distant shell is not its existence, but its instability. The Oort cloud is not a stable fortress wall. It is a teetering reservoir of potential destruction, perpetually balanced on a knife's edge. The gentle gravitational nudge from a passing star, the subtle pull of the Milky Way's tides, or the silent transit of a rogue planet can dislodge one of these frozen relics, sending it on a new trajectory. For most, that path leads into the eternal darkness of interstellar space. But for a select few, the new orbit points inward, toward the warm heart of our solar system. This is the genesis of a long-period comet, a visitor from the absolute outer dark. The true terror of such an object is its stealth, because it comes from any direction in the sky and on a highly elliptical orbit that can take thousands or even millions of years. Our surveys are practically blind to its approach. By the time we see the faint whisper of a coma, the cloud of gas and dust beginning to boil off its surface as it nears the sun, it could already be alarmingly close. There would be very little warning, perhaps only a few months or a single year before it reached the inner planets. Unlike the predictable orbits of near-Earth asteroids, this would be a complete surprise, a ghost from the outermost reaches suddenly appearing in our celestial neighborhood with murderous intent. The impact of a large Oort cloud object, several miles across, would be an extinction-level event far beyond any historical precedent. It would not just be a local catastrophe, but a global firestorm. The initial flash of heat would ignite continents. The seismic shock would trigger worldwide earthquakes and volcanic eruptions, and the debris ejected into the atmosphere would blot out the sun for years, collapsing the food chain and plunging the world into a deep, permanent winter. This is not a Hollywood fantasy. It is a scenario written into the geological record, a fate that has befallen Earth before and will inevitably come again. The Oort cloud is a loaded gun pointed at our planet, and the galactic triggers that can fire it are entirely outside of our control or prediction. We live our lives under a silent, frozen sword of Damocles, never knowing if the next faint speck of light in a telescope will be a beautiful celestial visitor or our final, icy executioner. The most terrifying prison is one you cannot see, touch, or even prove exists. What if the universe, with all its black holes, dying stars, and cosmic voids, is not the ultimate reality, but merely a fabrication? This is the simulation hypothesis, a theory that suggests our entire existence, from the smallest atom to the largest galaxy, could be an intricate simulation running on a computer of unimaginable power, built by a civilization far more advanced than our own. The logic, once you follow it, is deeply unsettling. If a civilization can ever reach a level of technological maturity, it would likely possess the computational resources to create vast, detailed simulations of its own history, or of entirely fictional universes. And if such a civilization could run even one such simulation, then it could run billions of them. Statistically, the number of simulated minds would quickly dwarf the number of original biological minds. Therefore, the odds are overwhelming that we are not the original beings, but the simulated ones, living out our lives in a reality that is, for all intents and purposes, a sophisticated video game. This idea transforms every aspect of our existence into a potential source of dread. Your memories, your loves, your deepest fears could all be lines of code written for a purpose you cannot comprehend. The laws of physics are not fundamental truths, but merely the rules of the simulation, parameters set by the programmers. The speed of light is not a universal constant. It is the processing speed limit of the cosmic computer. The eerie quantum behavior of particles, where they exist in multiple states until observed, could simply be a rendering optimization, a way to save processing power by only calculating the precise details of reality when someone is looking. This explains nothing and everything at once. The profound silence of the Fermi Paradox could mean we are in a contained simulation, isolated from other programs. The inexplicable fine-tuning of the universe's constants, which seem perfectly set for life to emerge, could be evidence of intentional design by the architects. Even the glitches we might dismiss as quantum weirdness or measurement error could be literal bugs in the system, moments when the facade of reality momentarily flickers. The ultimate cosmic horror is not that we are alone in the universe, but that the universe is not really there at all, and we are just ghosts in a machine we can never escape, playing out a script whose author we will never meet. We have journeyed through 25 cosmic terrors, from the grotesque death awaiting a human in the vacuum to the silent, ticking clock of the universe's own heat death. These are not fictional monsters, but realities woven into the fabric of space and time itself. We have encountered invisible killers like cosmic radiation and rogue black holes, witnessed the destructive potential of our own star and the ghostly prison of our orbital debris. We have seen how the universe can be erased from within by a quasar's heart, or from without by the relentless push of dark energy. We have pondered the profound silence of the Fermi Paradox and the chilling possibility that our entire reality is a simulation. This grand tour reveals a cosmos of breathtaking duality, a place of sublime beauty and profound terror, often existing side by side. The same forces that sculpt majestic nebulae and spin galaxies also create the conditions for absolute annihilation. Our place in this vast, mysterious cosmos is therefore both insignificant and profoundly precious. We are a flicker of awareness in an unimaginable expanse, living on a fragile world suspended between countless horrors. Yet we are here, able to look up, to question, and to feel that awe mixed with dread. It is this very capacity to understand the darkness that makes our fleeting moment of consciousness so remarkable. So we turn the question to you. After hearing these 25 space horrors, which one resonates most deeply with your own sense of cosmic fear? Was it the slow death of the sun, the silent approach of a rogue planet, or the existential dread of the Boötes void? Share your thoughts in the comments below. And if you are ready to continue exploring the mysteries of the cosmos, subscribe for more journeys into the unknown.